All right, we're going to continue with part 3 of lesson 9.4. We just have 2 more examples. So here we have some word problems, and we're going to set these up, and we're going to be able to use our trigonometry with tangent to solve. So number 8. This is also workbook page 261. An environmentalist wants to measure the width of a river to monitor its erosion. From point A, she walks downstream 100 feet. So here we are from point A, walking downstream 100 feet, and measures the angle from this point to point C to be 40 degrees. So from this point here up to point C, so this dashed line here, that angle inside here is 40 degrees. We want to know how wide is the river. So what we're looking for is we're looking for this length right here, AC. So let's call AC X. We're trying to now solve for X. So since we're walking straight down the river, we know that this is a right angle. So we have a right triangle. With this 40-degree angle, we have side X is what we're trying to find. That's the opposite side. And then this 100 here is the adjacent side. So since we know the opposite and the adjacent, we can use the tangent function. So we can say that the tangent of 40 degrees is equal to the opposite, which is X, divided by the adjacent, which is 100. Again, taking tangent of 40, putting it over 1, I'm going to then cross multiply. So X times 1 is simply X is equal to 100 times the tangent of 40 degrees. And again, I'm going to put that into the parentheses so you guys get used to knowing that that's one whole thing together and you can't separate it. Now we're ready for our calculator. So again, this is what we call calculator ready form. And so we're going to plug that into our calculator. So go ahead, type it in, 100 times the tangent of 40 degrees, whichever way you need to for your calculator. And you should end up with X is about 83.9. It says round to the nearest 10th. So 83.9. We'll write our sentence for our final answer. The width of the river is about 83.9, don't forget your units, feet. And there we have it. Now, part B says 1 year later, the environmentalist returns to measure the same river. From point A, she again walks downstream 100 feet and measures the angle from this point to point C to now be 51 degrees. So let me just quick make a sketch of the diagram again. So here we have point A. And so the width of the river is changing. So this is point C up here. So we're walking downriver again from point A downriver, still 100 feet. And then when we measure the angle to the point C, the angle has changed and this angle has now become 51 degrees. So again, we're looking for the width of the river. So we're going to look for this segment right here, segment AC. This is a right angle. And so we'll have that be our new X. So to calculate that, again, we can use the tangent because we know the opposite and the adjacent. So the tangent of 51 degrees is equal to X divided by 100. Put this over 1 to cross multiply. So X times 1 is X equals 100 times the tangent of 51 degrees. So then plug into our calculator. This is calculator ready form. We get that X is about 123.5. Okay, so that's the new width of the river, but then the question doesn't actually just ask us that, but it says by how many feet has the width of the river increased? So we know that the increase is going to be the new the new minus the old. So the increase will be the new width, subtract the old width. So our new width is 123.5 minus 83.9 for the old width, and we have 39.6. So again, write that out in a sentence. So the width of the river has grown about 39.6 feet. And there we have the width of the river. All right, question number 9. Question number 9 has to do with angle of elevation. So it says a boy flies a kite at an angle of elevation of 18 degrees. And so let's think about this. So here is our boy flying his kite. It's a terrible kite. Anyways, the boy is flying his kite. I'll draw a little thing hanging down from the kite. Whee! And it says the angle of elevation is 18 degrees. The kite reaches its maximum height 300 feet away from the boy. What is the maximum height of the kite? Okay, so the maximum height of the kite is going to be here, the top all the way down. Okay, and then the distance from the boy, it says that the maximum height is 300 feet when the distance from the boy, let's get this labeled, 300, oops, I read that incorrectly. The kite reaches its maximum height 300 feet away from the boy. Okay, so that's going to be our height, but the 300 feet away from the boy, we're going to have here when the kite is there. So that's going to be our 300 feet. And then that's going to make a right angle with the height that we want to find. And it says that the angle of elevation is 18 degrees. So remember, angle of elevation was kind of from our horizontal and then going up towards something. So this here is going to be 18 degrees. So since the H is across from the 18, that's the opposite side, and the 300 is the adjacent side, we can use the tangent again. We can say the tangent of 18 is equal to the opposite, which is H, divided by the adjacent, which is 300. Then our H is equal to 300 times the tangent of 18 degrees. Calculating that on our calculators, we get, and again, if you have to do it separately, you're going to get 300 times about 0.325. This is then about 97.5. So we'll write our sentence. The maximum height of the kite is about 97.5 feet. And this is the last question that we're going to be doing for today's lesson. So now you can look on Big Ideas Math and you can complete the homework for lesson 9.4.